So the goals for this lab, first we're going to talk about something called the Walker circulation. Then we're going to talk about the conditions that lead to El Nino and La Nina, and then I'm going to have you looking at something called a Tau Triton array. And it has some really cool data that helps us determine, are we in an El Nino or are we in a La Nina? Alright, so grab a drink, strap in, let's do this. Okay, so first, let's talk about where this all comes from. So there is a global circulation. So last class I talked about what's called the jet stream. That's a type of global circulation. Well, there's another type of global circulation that takes place in the equatorial Pacific called the Walker circulation. So here's how it works. Along the entire equator, there is this band of winds called the trade winds. And the trade winds blow from east to west. Very different than the jet stream, which blows from west to east. The trade winds blow from east to west. Now, as they're blowing from east to west, they're actually traveling, they're skimming right over surface ocean waters. And surface ocean waters get first crack at sunlight. So now you have this wind blowing over those surface ocean waters, and what it's actually doing is it's actually causing those waters to be skimmed off the top and pushed further west. Basically what happens is the warmest surface waters end up getting blown over to the western half of the Pacific Ocean. And so what ends up happening is you get this really large body of very warm water in the western half of the Pacific Ocean. And warm water leads to warm air. Warm air rises. As warm air rises, it expands, cools, and condenses, and that creates thunderstorms and stormy weather. So typically what happens is the trade winds blow from east to west. All of that warm water gathers up in the western half of the Pacific, and that creates warm rising air and very stormy weather. Now, on the other hand, in the eastern Pacific, all the warm water has been pushed away. What's left behind is this cooler water from below that rises up, and this actually causes this thing called the thermocline, basically the boundary between warm surface water and cold deep water, to rise up as well. So what we end up getting is in the eastern half of the Pacific Ocean, we end up getting a lot more cool water. Cool water leads to cool air. Cool air is sinking air. And so in the eastern half of the Pacific, we have sinking air, and therefore sinking air compresses. You don't get clouds in this case. And so typically what we end up getting in the eastern Pacific is much calmer, clearer, I almost like to jokingly say sunny weather. So you get stormy weather in the western Pacific and clear and boring weather in the eastern Pacific. And so this is the entire component of the Walker circulation. And this is actually the neutral case. This is the normal. I like to jokingly call this la nada, the nothing. Basically nothing is happening here. In this setup, all that we have is warm ocean waters in the west, cold ocean waters in the east, rising air and stormy weather in the west, sinking air, and therefore sunnier weather in the east. Now with that said, what happens in an El Nino? Well, an El Nino is actually a phase of the Walker circulation. And here's what happens. Those trade winds that were skimming all of that water and moving it to the western Pacific actually slacken off, and in many cases even reverse. And the reversal of the trade winds then causes warm water to begin to collect over the eastern half of the Pacific Ocean. And what